Good afternoon, everyone, and welcome to our 10th instalment of our Practitioner Education Series, where today we'll hear from Nicholas Eastmuir, who's a team leader in the Proactive Inspections Services, and Alex Glennon, who's a Senior Fire Engineer, Safety Engineer in Technical and Regulation at the VBA. The purpose of today's webinar is to discuss Proactive Inspection Program findings as they relate to separating walls. My name is Stuart Draffin, and I'm the Director of Audits and Inspections at the VBA. I'd like to begin by acknowledging the traditional custodians of the land on which we meet today, which for me is the Wurundjeri tribe of the Kulin Nation, and pay my respects to the elders past and present, and I extend that respect to Aboriginal and Torres Strait Islander peoples who may be here with us today. The VBA launched its Proactive Inspections Program, or as we call it, PIP, in 2015. And it's involved the checking of building and plumbing works under construction with the purpose of reducing non-compliant building and plumbing work in Victoria. During today's session, we'll be looking at PIP building inspection findings for separating walls, including the review of a number of photographic examples of what we've found in the site, on sites, and describing why they are non-compliant. We'll then discuss what the regulations require to ensure compliance. Later in the session, we'll have some time to answer some of your questions. So I draw your attention to the Q&A icon at the bottom of your screen. And if I've got to emphasize to you, please use the Q&A icon, not the chat function. We'll be monitoring that Q&A space for your questions throughout the session, and we'll be able to address them with time remaining at the end. A final reminder, today's session is being recorded. We'll be making the session available on our YouTube channel shortly after today's session, along with our previous webinars. I'll now hand you over to Nicholas Eastmuir, who will take you through the presentation. Thank you.
Hi everyone, and thank you for attending today's Practitioner Education Series. My name is Nick Eastmuir, and I'm a team leader within Inspection Services. Today we'll be talking about fire separation, specifically between adjacent Class 1A dwellings and their separating walls. Our team have been working hard to inspect the construction of multi-unit residential sites. Since the 1st of July, over 150 have been inspected, and I'm eager to share the common non-compliances that we are observing. We hope that this presentation will increase your understanding of what the separating wall is required to do and bring attention to the requirements of installing these walls correctly. As usual, when it comes to a topic on anything construction related, we will start with the National Construction Code, Volume 2, 2019, and we'll refer to it as the NCC. I promise we won't spend long in the NCC, so we can quickly get into the concerns we are seeing on site. The relevant performance requirement relating to the spread of fire is P 2.3.1. This is what we must achieve. If we leave it at its most basic principle in that a Class 1 building must be protected from fire. So now that we know what we must achieve overall, how do we do it? This is where we turn to part 3.7.3.2 of the NCC for the requirements of separating walls. We know that most separating walls on site are lightweight construction, so let's remove the permit related items so we can keep this down to, again, its most basic principle for on-site construction. This is that our separating wall must obtain an FRL of not less than 60-60-60. I will make a big point here in that this test requires the wall to meet the required FRL on both sides of the wall. This is unlike a typical external wall of a single dwelling in that it would only require the FRL on one side, being the external face. There are other elements within this clause that relate to a lightweight separating wall that we will touch on, but let's leave the requirements for the relevant building surveyor assessing the permit documentation. The FRL of a building element is broken down into 3 components and is always expressed in the same order: structural adequacy, integrity, and insulation. Now that we know what the NCC requires, let's start looking at some of the walls used to meet these requirements. Regardless of the separating wall being installed, we must remember that it is a tested system. System is the one word that I'm trying to emphasize here by showing the different manufacturers' details when it comes to providing the required fire rating. If we can start to understand how these systems work overall, it will give us a better understanding of each component and its role within the system. Now, let's have a look and see what a separating wall does to achieve our requirement and prevent the spread of fire. How these systems work in the event of a fire is perfectly illustrated in the diagram located within the GTEC installation guide. As I previously mentioned, this system must obtain the required FRL on both sides, as we cannot assume where the fire will start. If a fire were to occur, then we need to make sure that the separating wall will remain functioning and not be compromised. If it was compromised, then we will no longer meet the performance requirement. These systems are designed so that in the event of a fire, the connections between the wall and the frame melt. This detaches the separating wall from the frame exposed to fire so that if the structure collapses, the separating wall will remain in place to protect our remaining Class 1 from the spread of fire. Please note that it is for this reason the substitution away from the aluminium clips will compromise the entire system from the get-go. Now that we know how these separating walls work if a fire occurred, we can start to appreciate that the clips are a crucial aspect of the wall system. Let's look at what we observe on site. Here we have our separating wall, which in this instance is a boral shaft liner. We can see here that it is intersecting the parapet of the adjoining dwelling. You will notice that on this side of the wall, there are no clips visible. During the inspection, we observed that they had only been installed on one side of the wall across the site. This installer was gambling on where a fire would start, and if the fire were to be on the adjoining dwelling, the fire would spread uninhibited. Now let's compare this to what is required based on the manufacturer's installation guide. You can see now where the clips are required to be installed on both sides of the wall. They were clearly missing from the photo, and it is a very common non-compliance that we come across. On this system, the clips need to be installed to the underside of the top plate and fixed into the metal H-stud of the shaft liner wall. The required spacing is at 600mm centers, and amazingly enough, these panels are 600mm wide. Therefore, every stud should have a clip, which shouldn't be too hard to remember when we go back out on site. Following on with our shaft liner system, this one is manufactured by Gyprock. We are looking at the junction between the ground and first floor areas of the adjacent Class 1s. You can see here that the additional layer of protection has not been installed, but let's keep our focus on the clips for the moment. You can see that they have been installed, however, they are penetrating the shaft liner rather than the party wall stud. This example clearly shows that even with inconsistent fixings, eventually we can get one right. Let's see what the system requires. Here you can see that the Gyprock separating wall system not only requires the additional layer of fire stopping, but again reinforces that these clips must be installed into every H-stud on both sides of the wall. When we have penetrations into the shaft liner, we are compromising the fire rating of the system, and we can no longer assume we comply to prevent the spread of fire. Same thing as last slide, but a different site and back to the boral system. This area is showing the floor junction between the ground and first floor of adjacent Class 1s. Unlike the previous slide, we can see here that the additional layer of fire stopping has been installed, but again, no clips have been provided to this side of the wall. Let's then compare back to the installation guide and see if this is as per our tested system. This detail is quite clear in what is to be constructed. The clips must be installed on both sides of the wall and fixed through the additional layer of fire stopping and into the H-stud. It is important that we follow the installation procedure when installing these systems. The manufacturers have designed a product to facilitate a smooth construction process when on site. If we deviate from it, we create our own risks. Looking at the installation procedure in this case, the clips are to be installed progressively during construction and fixed into the party wall stud. Each manufacturer has their own installation details, but remember, to ensure we can prevent the spread of fire, we need to install the separating wall as per its test to confirm the FRL of 60-60-60. If we have a look at this GTEC separating wall system, you can see that in the photo, the clips on this wall have been installed directly into the shaft liner and connects to the stud rather than the underside of the top plate. During this inspection, clips had been installed on both sides in a similar fashion. So is this what our system is meant to look like? Let's compare. We can see here that the manufacturer clearly states that there should be no penetrations into the GTEC Protect board. When we install clips like this, we are clearly compromising the fire rating and it should not be occurring. It will also raise other issues regarding the transmission of noise, but we will touch on that later. Again, this product nominates that the clips are to be installed 600 mm horizontally, and yet again, our sheets are 600 mm wide. So again, on this system, every stud should have a clip appropriately installed. The clip installation is not just limited to the junctions of floors, but also applies to the fire separation within the roof area of the adjoining Class 1 dwellings. Continuing with the GTEC system, but on a different site, we are now looking at a separating wall that is including a pitched roof. You can see here that the dividing wall has the additional layer of fire protection. It has the clips installed at the underside of the top plate and they're fixed into the separating wall studs. It's ticking all the right boxes so far. However, there are no clips installed to the underside of the truss top cord. These are required to adequately support the wall and facilitate the required fire separation between the roof areas. So now let's have a look at how this system is required to be installed to ensure we can prevent the spread of fire. We can see here that the manufacturer requires us to install clips on both sides of the wall. These are attached to the underside of the top cord and fixed directly into the H-stud of the separating wall. In this diagram, we again confirm that the clips to the underside of the top plate are correct, and at this site we had clips on both sides of the wall. So close, but yet so far from being installed correctly. This is not just limited to shaft liner systems either. Here we have a Hebel power panel forming our separation wall. The area we are looking at is a junction between the ground and first floor areas of adjacent Class 1s. In this photo, again, we are not seeing the installation of brackets to this side of the wall. So let's again compare to see what we can see when compared to the manufacturer requirements. We can see here that the system requires the panels to be fixed on both sides. The base panel is to be connected to the underside of the top plate, and the top panel is to be connected to the bottom plate of the upper story in this section. We must also ensure that these brackets are within 600 mm of the connection in the power panel. Again, on this site, we observe the brackets were only installed to one side of the wall. Given the importance of these clips to maintain a functioning wall in the event of a fire, we all need to make sure that we are attaching it correctly. The examples just provided would not be able to function and provide the required objective, which is to prevent the spread of fire. Now that we have a clearer understanding of the importance of clips, we can move on to the alignment of panels. The alignment of panels is another regular non-compliance that we observe. As you can see in this image, we have a few things going on with this boral shaft liner system. We just covered clip installation and we will dive deeper into the additional layer of fire stopping later on. So let's pay specific attention to the offset of the H-studs. What does our tested system require us to install and why? Let's have a look. We can see here that the borel shaft liner system requires the studs of the upper level to align with the studs below. These studs need to align vertically so they can transfer their own loads appropriately down into the footing. Where these panels are offset, we are deviating from the tested system and can no longer ensure that the required fire separation is being maintained. We must always seek advice from the manufacturer to confirm compliance when this kind of construction occurs. Let's have a look at other areas that this is seen, but on a Gyprock system. Here we can see the installation of a Gyprock separating system, and it has the H-studs offset. We can see here a clip has been installed into the H-stud, but has not been secured to the underside of the top plate. It's not much use if there was a fire in the adjoining dwelling. There is no additional layer of fire stopping installed either, but this gives us another good look at the alignment of how these panels are connecting. We can see that this area is at the junction between the ground and first floor areas of adjacent class 1s. So let's compare this to what the manufacturer requires. We can see here that within the checklist provided by the manufacturer, the second item is to ensure the walls, all H-studs, align at each story except in the roof space. The detail shown tells us that once we get to the roof space, we can have an offset of a maximum 300 mm in the stud alignment. This cannot be allowed anywhere else in the wall, and this will not comply with the tested system. Whilst we are on the alignment of panels, it is important that we then look to ensure the correct H-studs and tracks are installed. You can see in this photo that a borel shaft liner system has been installed. Let's highlight quickly that the additional layer of fire stopping does not extend the full length, but we will also cover that later on. If we focus on the junction where the 4 panels are meeting, we can see that there is a clear gap in the connection due to the track being substituted by a H-stud. Let's see what the manufacturer requires us to install on site and see if we can be sure that this will provide our required fire rating. Now we can see what the cross section should look like. It is clear that on this site, we have substituted the H-stud for the party wall track. We have not provided a continuous steel track running the length of the wall, and the studs are not terminating correctly. If this had remained as is, in the event of a fire, this would have failed due to this area. Alignment of panels is very obvious when you're on site. Please do not overlook this area. So now we can move on to the floor junctions, which we have touched on a few times now. You will notice that most shaft liner systems will require an additional layer of fire stopping when it comes to not only floor, but ceiling junctions. This is due to the increased fuel load seen in these areas caused by the intersecting timber members. Again, this wall must maintain its FRL for 60 minutes, and this is where a lot of the hard work will occur. It is critical that we get this additional layer installed correctly, and it is again another common item we observe as non-compliant. In this photo, we can see that a Gyprock system is being installed. We are looking at the first floor junction of adjacent class 1s and can see that the additional layer is only extending below the junction and has a lot of fixings along the base. So let's have a look and see how this compares against what needs to be installed. We can see here what the Gyprock system requires from us. The additional fire stopping must extend a minimum of 200 mm past the floor and ceiling junction and be fixed to the shaft liner with laminating screws at 400 by 400 spacings. On this site, we were not getting the required coverage above the floor joists, and our very enthusiastic person laminating the additional fire stop has decided to increase the fixings due to not being able to install the additional rows of screws. This compromises the system. It's good to see the panels are aligning though, and the clips have been installed. Let's have a look at the same thing, but on a GTEC system. Again, we are looking at the junction of floor joists to the separating wall between adjacent class 1s. You can see in this photo that we have the additional layer installed and our panels are aligning, which is a good start. But again, we bring it back to the tested system and the required installation guide. So let's compare. We can see here that our additional layer of G-Tech fire is required to extend a minimum 150 mil above and below the floor or ceiling. We were not achieving this on site. And again, thinking about the additional fuel load sitting in this area, we can no longer be assured that we will maintain the FRL of 60-60-60. So let's now look at a borel system for the same thing, and I'm sure you are getting used to the idea of what is required. So again, we have our borel shaft liner at the junction of the floor joists. These panels are not aligning and our coverage for the additional layer is minimal. Let's look at what we need to install to again ensure we prevent the spread of fire. The additional layer for the borel wall is also required to extend a minimum 150 mil past the floor joist as shown within the detail. This is clearly not being achieved on this site and will only limit the separating wall's ability to prevent the spread of fire. We have to make sure that these additional layers run the full length of the wall. As you can see here, and as touched on previously, the additional layer of fire stopping terminates well short and leaves the remainder of the dwelling exposed at this junction. This is not in accordance with the tested system and leaves the occupants at risk in the event of a fire. So let's move on to the ceiling junctions. It is the same setup in that there is an increased fuel load in this area and requires particular attention. Here we can see a borel system being installed. We are looking at the parapet junction between adjacent Class 1 dwellings. We can see that no additional layer of fire stopping has been installed and neither of the clips. Not installing the clips works out well in this scenario, given they need to go through the additional layer of fire stopping and into the H-stud. So let's look and compare this to what our manufacturer installment requirements are. We can see here again that the additional fire stopping is required. It is required to extend 150 mil past both sides of the gutter and ceiling and clip to the frame appropriately. If left like this and a fire occurred in the adjacent unit, the roof area will be left unprotected and fire will be able to spread. Let's now have a look at the requirements for a Gyprock separating wall. As you can see from this photo, we already have some concerns with the clip installation as they are not installed into the H-stud. And we also do not have any additional layer of fire stopping. This is where it is imperative that we always refer back to the manufacturer's guidelines to ensure we are installing it correctly. So let's look at what is required. In a Gyprock system, the additional layer of fire stopping is to be installed to the top of the shaft liner and must extend a minimum 200 mil below the ceiling. As you can see here and hopefully start to appreciate, there are different spans required for different systems. Do not fall into the habit of assuming all systems are the same. When it comes to laminating the additional layer to the shaft liner, we need to again make sure we are doing it correctly. As you can see in the photo here, the laminating method chosen for the borel shaft liner was to use nails with a very inconsistent spacing. As always, let's turn back to the required installation. We can see here that the tested system requires us to utilize laminating screws at 400 mil max centers. This is a substantial deviation from the tested system. With incorrect fixings and spacings, we are no longer ensuring that we can prevent the spread of fire. You can see here we are looking at the top of the separating wall, which again is a borel shaft liner. The very obvious concern we can see is that the separating wall does not go to the full height of the dwellings and will only facilitate the spread of fire. We can see the additional layer has been provided, which is a great start, but again, nowhere near its required location. Despite me saying not to make assumptions, it is safe to say that regardless of the system, we must make sure that it extends the full height of the Class 1 dwellings. So again, let's revert back to what the manufacturer requires when terminating at a parapet. We can see clearly that the shaft liner is to extend beyond the timber frame and then be packed with a suitable mineral wool packer to then seal the top gap. The additional layer is also again required to extend 150 mil past the gutter and ceiling. This has not been installed correctly, and we cannot demonstrate that this construction will prevent the spread of fire. So let's again look at the roof junction. On this site, we have a heaver wall that was utilized. It is important to also keep in mind that these systems will throw back to the NCC for the allowance of members to cross a separating wall. Similar to the shaft liner systems, we have to ensure that all gaps are appropriately sealed. As you can see in this photo, the non-combustible roof battens are crossing the separating wall, and there are gaps between the hebel and the roof lining. So let's have a look at what is required by both the manufacturer and the NCC. As we can see here, the hebel installation guide requires us to fully seal the gaps with the required Bradford Fire Seal party wall sealer with 10% compression. This is not the case for what we saw on site, and left open, the wall will not prevent the spread of fire. You will notice that the detail also nominates the NCC clause 3.7.1.8 subclause D. This clause is referencing the 2016 version of the NCC, but the relevant provision for the NCC 2019 is 3.7.3.2 with subclause C, which has been shown. This clause is important as it details the only members that are to cross a separating wall. In this instance, we have non-combustible roof battens, which is allowed providing we terminate the wall appropriately. The infilling of these gaps is shown within II of this clause. But again, the wall system is tested to ensure this aspect of the NCC is covered, and the note is closing the loop between these two documents. So now we can look at how we are terminating the separating wall at an external wall. In this instance, we have a boral shaft liner system being installed and is viewed from above. We will touch on the external track required at the end of the panel shortly. However, let's get into the hot topic right now, which is when we utilize EPS as an external wall. This is a big concern when the EPS forms a continuous horizontal link across the shaft liner system, which is being shown here. Let's look closer at the external wall junction and what is required. So as you can see here, the boral shaft liner system has a detail on how to terminate appropriately with a lightweight external cladding. This detail is important to understand. It allows us to terminate at the external cladding, but as we are all well aware, EPS is combustible. In the current example, our shaft liner has an FRL proven on both sides and takes into account how it interacts with the external wall. Where we have EPS as our external wall, once it is exposed to fire, it will not be able to maintain the FRL required of 60-60-60, and it will spread to the adjacent dwelling. We then no longer comply with the performance requirement, which was to protect the Class 1s from the spread of fire. In this situation, the EPS was later replaced with hebel to achieve compliance with both the manufacturer's installation guide and the NCC. Please keep an eye out for this occurring and speak to your relevant building surveyor for further advice. Continuing with the termination at external walls, let's have a look at this hebel installation. As you can see in the photo, the separating wall stops well short of our external wall. If you can put your arm from one class 1 to the other, then we will not comply. So let's have a look at what this should look like on site. As we can see here, the HEWA product allows for overhanging walls. It is important that the power panel is installed so that it can terminate appropriately with its external wall. If this cannot be achieved, then once again, we won't prevent the spread of fire. This is not limited to one system either. We can see here that our boral shaft liner is not extending the full length of the dwelling, and the base track was terminating in line with the end of this panel. These areas cannot be overlooked, and the entire length of the class 1 must be protected. Within this detail, you can see that a continuous party wall track is required to be installed to the end of the wall panels. Within the installation guide, the system allows us to cut the last panel to size. We should not leave areas like this open to facilitate the spread of fire. In this situation, we were looking at a boral shaft liner where it is intersecting an external masonry wall. We can see that the separating wall is spanning the whole length and the additional layer of fire protection installed at the roof area. It is important to get these areas correct, as any gap, which includes the rebate, will not prevent the spread of fire. So let's look at what is required on this system, as this is another very common non-compliance that we observe. You can see here that for the shaft liner, the shaft liner is to be covered by a continuous compressed mineral wool packer, and the sizeolation is to extend over this to ensure it is not exposed to weather. This detail also shows that a control joint is required opposite the shaft liner. This is handy when it comes to doing inspections. If you are doing a final and the control joints have not yet been weather sealed, have a look through and see what is visible. If you can see a shaft liner track, well then you know there is nothing infilling the rebate. So hopefully now we have a better understanding of external wall junctions. We'll now jump into the sealing of separating walls. This item is very commonly overlooked, as most of our attention turns to looking at everything above the base of the wall, but it is critical that we seal the base. This photo is showing a boral shaft liner system from above. Its base track has been secured to the slab, but there is no evidence that it is being sealed on either side of the wall. So again, let's have a look at what the manufacturer requires. As you can see within the manufacturer's installation guide, step 5 requires us to apply a continuous seal along the base track on one side. They have also nominated suitable products to be utilized as part of this system. If we do not seal the base track, we cannot be certain that we are preventing the spread of fire. Hebel and other aerated concretes require a bit more attention when it comes to the sealing of these walls. In the photo attached, you can see that we have concerns with both the damaged panels and how the panels are suitably sealed to prevent the spread of fire. Damage we will cover a little later on, so if we first focus on how we would adequately seal this wall to maintain the FRL at all the joints. However, noting that when it comes to control joints, other specific installations are required. So now we can see the before and after image of the same wall. Bringing this back to its installation requirements, we first need to make sure that when we are installing these panels, correctly. To do this, we must follow the adhesive requirements. It asks that we must have a joint that is at least 2 to 3 mil thick after suitable pressure has been applied to the panels to ensure an appropriate attachment. The force applied should make the excess adhesive protrude, which then gets scraped off, ensuring a tight seal across the panel. To then seal the wall, any other remaining gaps or movement joints must then be sealed so that both the fire and sound ratings can be achieved. So now let's move on to damaged panels within our separating wall. Here we can see that on-site storage plays a big part in keeping these materials fit for purpose. If they are laid around in high traffic areas, trades will walk on them. So again, let's go back to the manufacturer's installation guide, which in this instance is Boral. Here we can see that the first item under the don't section is not to use damaged panels. In this instance, the rectification works were sought from the manufacturer and subsequently installed. You can see that the repair work extends well beyond the area of the damage. This is not only due to the reduced effectiveness in the case of a fire, but also because the wall systems have other tests required to confirm things such as its resistance to damage, deflection, and surface indentation. For those interested, these tests are outlined within the NCC 2019 Volume 1 Specification C1.8. Again, illustrating the point for the damage. In this photo, we can see that the Gyprock panel has been damaged and has seen better days. Different manufacturer, so again, let's have a look and see what they say in regards to damage. We can see here that when it comes to the Gyprock system, any physical damage to either the core or paper face must be replaced. And on this site, that is exactly what they did. Not all systems have the associated testing to confirm the repair works can maintain the wall system. It is for that reason we always go back to the manufacturer to determine the appropriate remedy. We have just covered a lot of the concerns that proactive inspections have found for aspects relating to the fire separation. But as we now hopefully understand, this is a system that we are installing. The wall itself has to do a lot more than just provide fire separation. It must also provide the required insulation against the sound transmission. It is important to understand the dual purpose of these walls when it comes to the details within the installation guide. So we will now look at the air gap. As you can see here, we have a Gyprock fire separating wall system. It is not providing the required gap between the shaft liner and the timber frame, and on some sites we see the shaft liner in direct contact for the full length. So let's have a look back at the required installation detail. As you can see here, and like shown on previous slides, we have to provide a 30 mm gap to each side with an allowed 10 mm variance. Again, this is to ensure our class 1s are insulated against the transmission of airborne and impact generated sounds. When we get this gap down to near 0 mm, it is going to significantly impact the ability for the wall to comply with the sound transmission requirements. These requirements around sound insulation are also not just limited to the air gap. So let's have a look at our next slide. As you can see here, we have again our Gyprock separating wall system. Due to everything we've just gone through, we can already start to see some areas of concern with both the peeling of the paper and the location of the clips. Previously, we were highlighting that the areas the clips are required and their purpose during a fire. So what happens if we install them at both the bottom plate and at noggings? As we can see, when it comes to acoustic performance, the use of additional clips within the story will reduce the acoustic performance of the wall, and it may not meet the requirements for discontinuous construction. This is a commonly overlooked non-compliance, and now that we know the implications of the wall systems, we hope to see less type of this installation. Continuing on with our air gap, we commonly see this space filled with services. As you can see in the photo here, we have services directly fixed to the GTEC separating wall system and running within the air gap. Based on the requirements of this wall, the manufacturer states that all services should be run through the framing and that to maintain acoustic performance, the service pipes must not be in contact with the GTEC system, which has not been achieved in this scenario. This is not limited to just the GTEC system either. So you can see here we have our boral shaft liner providing our separating wall. And again, we can see our services directly fixed to the wall, which will make us again have to consider the transmission of noise. It's pretty clear that the manufacturer states to maintain acoustic performance, service pipes must not be in contact with the shaft liner, and that all services should run through the timber frame. This is again evidently not what we are seeing at this site. So again, let's have a look at a Gyprock system with the same issue. Here we can see our Gyprock separating wall. You can see that the electrician has enjoyed his day running the cables within the air gap in lieu of through the timber frame. We can see here that the required installation for services is ideally through the timber frame, or if provided in the gap, we must maintain a minimum of 10 mm clearance to the shaft liner. In this instance, we would need to see that all cables were fixed back to the stud to ensure this could be achieved. Maybe not the most time-effective strategy overall. All right, let's move on to our last concern that unfortunately we are seeing far too often, and a big apologies that this may time with your lunch, but let's get on to mold. Mold is not a nice thing to see, and it personally takes me back to my earlier time inspecting illegal boarding houses when working for council. These separating wall systems, like touched on previously, do more than provide fire separation. These walls are also linked to the acoustics that we just covered, and they are still individual components coming together to provide a safe home for the occupants. As you can see in this photo, we have a Gyprock wall system that has been exposed to weather for too long and is now experiencing a large amount of mold growth. If this is covered, it will only spread and then pose a serious threat to the health and amenity of the occupants. It is recommended that the shaft liner system should be protected from rain and not left exposed for any longer than 1 month, which obviously was not the case here. So let's see this in another system. Here we can see our boral separating wall is experiencing a large amounts of mold also. When it comes to the boral shaft liner system, exposure of components to the weather elements should be avoided. And if it's going to be exposed for a month or more, then it should be appropriately protected. If you see this on site, please do not cover the wall. The rectification costs will be a lot more later on, not to mention the risk to the occupant exposed while living at the dwelling. We hope that this raises the awareness of the issues we are experiencing on site. By no means is this an overall checklist for the installation of these systems. Always refer back to the manufacturer's guidelines for the correct installation of the product nominated within the building permit documents. The more eyes we have looking at these walls to ensure they comply, the quicker we can provide a safer built environment for the public. Thank you for your time, and I will now pass over to my colleague Alex to briefly discuss a few fire safety performance issues relating to non-compliant separating walls.
Thank you, Nick. Good afternoon, everybody. My name's Alex Glennon, and I'm a Senior Fire Safety Engineer at the VBA. The Proactive Inspections team has identified some common defects, and I'd like to explore a couple of associated issues. Firstly, how do these type of defects affect the wall's performance in fire? To consider this, we'd have to look at how fire spreads and what the NCC requirements are. I'm sure many people are familiar with the basics, but fire spreads via conduction, convection, and radiation. Conduction is a transfer of heat through solids. An example of this is how heat transfers from face to face through a solid wall panel from higher to lower temperatures. Convection is the transfer of heat through fluids. An example of this is a hot smoke layer filling a room and transferring heat to the wall surface where it's in direct contact. Radiation is the transfer of heat by electromagnetic waves, where physical contact is not required. An example of this is flames or hot smoke heating the wall from the other side of a room. Within a room, these mechanisms can occur at the same time to affect the fire resistance level in terms of its structural adequacy, integrity, and insulation, which are defined in the AS 1530 Part 4 fire test. To build upon what Nick mentioned before, the failure of structural adequacy occurs when a wall system loses mechanical strength as a result of increasing temperature, causing excessive deflection or collapse. An integrity failure occurs when a hole, crack, or fissure is created on the non-fire side of the wall that permits the passage of fire or smoke. In a fire test, this is when a gap gauge can be passed through the specimen, or there's sustained flaming for 10 seconds or more on the hole, from the hole, or when a cotton pad applied to the hole ignites within 30 seconds. An insulation failure occurs when the surface temperature of the non-fire side of the wall becomes hot enough that it could ignite combustibles touching the wall. In a fire test, this is when an average temperature increase of 140 degrees or a maximum temperature increase of 180 degrees occurs on the unexposed face. Shaft liner wall systems comprise a wallboard supported by steel tracking and connected at either side to a lightweight timber frame by aluminium clips. The intention is that the wallboard remains supported by the cooler, non-fire affected side of the wall for the duration of the fire without collapsing or losing its integrity and insulation performance. The wall systems provide fire resistance from the outside in, and because the wall is symmetrical, it achieves this one-way FRL in both directions. In this way, the system is a clever solution to external one-way FRLs. The wallboards are generally made of paper-faced gypsum plaster with additives to improve fire performance. Gypsum is effective because it has chemically bound water that absorbs a lot of energy in fire. Upon heating, the internal panel temperature remains at about 100 degrees for a significant duration until the water is largely evaporated. At about 100 degrees internal temperature, the panel becomes completely dehydrated but begins to significantly and rapidly weaken, shrink, and ablate, which can cause the panel to fall off or create large holes or gaps that permit the spread of fire and smoke. This is an integrity failure. The thicker the board, the better it would be expected to perform because of the increased mass and resistance to conduction, delaying heat transfer through the panel, which is the reason vulnerable areas require additional layer of fire-rated plasterboard, such as ceiling and wall interfaces. However, where damaged panels are used, which can reduce the effective thickness, or panels are penetrated by screws and nails, which have a higher thermal conductivity, as well as weakening the integrity, the heat will be conducted faster, speeding up the dehydration process, which will hasten failure of the wall. The shape and configuration of the board, such as using offcuts or misaligned pieces, can also affect the rates of heat transfer. Edges and corners are exposed on more than one face and are therefore heated more quickly. Inappropriate sealing of edges and gaps can exacerbate these edge effects, as well as permit the spread of flames and smoke. Finally, by incorrectly or not installing the aluminium clips, in the event of a collapse on the fire side, which is what the system is designed to do, it increases the chance of the wallboard will be damaged, pulled down, or just fall where unconnected. The wall systems, as correctly installed, have been tested to verify its performance in fire, and one or more of a combination of these small defects could compromise that performance, and therefore compromise safety in the neighboring building. Shaft liner systems are very good, but their performance is only as good as their installation. And without careful construction monitoring, once sealed, errors might only be discovered when the walls are needed the most. This is obviously true for all passive protection systems. The second thing I'd like to talk about is what options are available for addressing construction defects for separating walls. Hopefully an installer, inspector, or building surveyor would identify issues early, but if discovered late or on a large scale, could it be fire engineered instead of fixed? We've already identified that incorrect installation creates uncertainty, and there may be synergistic effects between the performance of different elements during a fire. The construction requirements for separating wall systems are prescribed based on test evidence, so obviously it's difficult to assess a wall that has an untested performance. Because the BCA is a performance-based document, there are options to use a fire safety engineering approach to justify the installation, although they are probably quite limited for this application. The performance requirement of Class 1 buildings is to protect a building against fire spread from its neighbour, and the DTS minimum standard is 60 minutes fire resistance level. There would have to be a good justification to reduce this, and it's important to appreciate that fire resistance level is a defined term in the BCA, and specified methods to determine the FRL are provided in Schedule 5. It's not possible to change a definition or the defined requirements of the schedule, although an assessment of the ability to resist fire to the degree necessary could be made using first principles or a comparative assessment. For lightweight construction, a comparative approach would typically require consideration of fire test data for similar systems that correlate with the proposed variations. For an absolute approach, a heat transfer analysis could be used to model temperature gradient across the wall system. However, both methods would need to consider the behavior of the components individually and as a system. And there's also an element of uncertainty with the phase change of materials affecting conductivity or failing in different locations at different times. So to analyze it appropriately could be complex. And due to the uniqueness of application and required assumptions, there may be a low level of confidence in the results. The performance solution should also be undertaken in accordance with the BCA Part A 2.2 and the Australian Fire Engineering Guidelines, including a brief and report with stakeholder consultation. So it's unlikely to have a quick turnaround, and a fire engineer may require additional trade-offs to compensate for any vulnerabilities in the wall. For these reasons, a fire engineering assessment may not be recommended. If the engineer wouldn't design a wall as constructed in the first place, it's unlikely they would or could support a defective wall. I would say the best approach is to speak to the manufacturer early for rectification options, or speak to an AS 1530 Part 4 NATA accredited laboratory to see if they think a determination could be appropriate as suitable evidence. If you do opt for a fire engineering approach, ensure that the fire safety engineer has appropriate specialization and experience in fire testing, with access to relevant test data demonstrating how different configurations perform, which may require extensive data from research and development tests. So that's all I wanted to say for now. I'll now hand over back to Stuart.
Thank you for that work, Nicholas and Alex. You've provided everyone a lot of information there, and actually provided some really tangible and real examples of observed compliance issues. And one of the things that I've taken away from it is the critical role of the manufacturer's system and their specifications being followed to the T. We've had a few questions come in. One of the questions relates to, can combustible external cladding be installed crossing the separating wall without a performance solution?
Can definitely answer that one, that no, it would definitely require a performance solution to be considered. If the EPS is used in external cladding, it will form a horizontal link between the dwellings, and we no longer comply with the performance requirement to prevent the spread of fire.
Right, thanks for that, Nicola. Another one relates to the lightweight construction products, such as the Boral shaft liner. Do they need to be installed by certified installers? That seems to be one of the questions that's coming through quite commonly.
I'll jump on that one as well. No, I would first suggest always read the manufacturer's installation guidelines specifically for their warranty sections. They normally say that they will recommend that a licensed trade or installer utilize their product, but read their liabilities first and their warranty conditions before making a decision.
Okay. There's a question here relating to, I suppose, the intermixing of one manufacturer's product with another. So different manufacturers to substitute for the installation process. Is that something we've seen, or is it something that's problematic? I think I know the answer to that one based on what you've shown me, but I'd like to hear it.
Yeah, I can definitely jump in. Alex, you can follow on if you like, if there's anything you want to add. But again, we can't substitute materials. We spoke about that with the clips. We have seen the aluminium clips substituted with the metal L brackets. This cannot be done, and it's the same. We can't cross systems and assume that it will work.
Right.
Yeah, I haven't really got much to add to that. It's pretty clear.
Yeah. And the other one coming through is quite a few people are expressing concern about these systems and the level of compliance or non-compliance that's been observed, and about whether they're a system that should be really used if they're not being used properly. And the questions relating to that talk about why don't we have mandatory inspections for this particular stage of construction to actually assure ourselves and the community that they are being installed correctly?
I think from a building surveying perspective, we can definitely understand that it's not a required mandatory inspection at this stage. I'd say that if anyone was surprised by anything that they've seen in this seminar, then look at the permits you're issuing. If you do have a multi-unit development, maybe have a look at section 35 of the Act, determine whether or not you think it would be appropriate to carry out an inspection. Know that they're not mandatory, but we might be able to just get ourselves to a state that we're comfortable in assuming that they are now being installed correctly. Perhaps even look at what's required for the occupancy permit. Do we need the checklist? Is a tick box enough? Do we need photos to confirm each element? I think it's about making sure that we cover ourselves.
Thanks for that, Nick. I'm just conscious of the time. I just wanted to thank everyone for participating and supporting this webinar series, and particularly today's session. It looks like we've had around about 800 people attend today's session, which I think is a very healthy interest from the industry in the topic. I think the information that's been supplied has been insightful and also tangible and real. I'd like to thank everyone for attending and your interest in it. If you want to review the material, this recorded webinar will be up on our website fairly soon. I'd also encourage you to make other members of your industry who may not have had a chance to attend today aware of it, so they can go back and view the material. It's an important exercise. This is about the safety of the community and the people who purchase and live in these buildings. So our intention is to try and improve, obviously, the compliance rate and its functional delivery of fire separation. Could I ask everyone to fill in a post-event survey? That'll really help inform our future sessions, both in terms of their content, but also how we present the material and make it available to you. As you'd be aware, this is our 10th webinar. We're always looking at opportunities to try and improve both the delivery and the content. So your feedback is really important in being able to make it relevant to you and members of the industry. We had one recently for site inspections and enforcement, which is on the webinar on our webpage already. So you might want to go and have a look at that one also. Finally, thank you everyone for your attention, your time, and particularly thank you to Nick and Alex for the work they put in preparing this information and presenting it. I think you'll find the information was particularly relevant and useful, and hopefully you've valued the opportunity to participate today. Thank you very much. I hope everyone has a great day, has a safe one, and look forward to seeing you out and about fairly soon. Thank you.